The birth of a star in the Eagle Nebula, one of the most famous images in Hubble's collection. The Pillars of Creation. This 408-pixel-wide image shows the core of the Eagle Nebula, a stellar nursery 6,720 light-years away. Within the dark silhouette of the nebula's walls lies the tightly packed cluster of stars known as the Pillars of Creation. The bright pink and red hues represent newly forming protostars, glowing balls of gas and dust still in the process of coalescing. More massive stars are born in these dense regions where gravity pulls together large amounts of material. The central pillar alone spans 1.4 light-years, equivalent to almost 9 trillion kilometers. Because the region is so active, the pillars have changed significantly since Hubble first imaged them in 1995. New stars have ignited, lasting expanding bubbles into the surrounding nebula. Meanwhile, cocoons of dust conceal others in their final stages of formation. To astronomers, the pillars serve as a natural laboratory to study the evolution of stars and planetary systems. Their dramatic appearance also captivates the public imagination, symbolizing both the creative and destructive forces of our universe. The Great Rift Valley in the Milky Way. Here we find ourselves along the Milky Way, our galaxy, and here is the center of the galaxy. There is a vast swath of dusty darkness, known as the Great Rift Valley. Stretching over 600 light-years, this is one of the largest features in the night sky, though it appears smaller because of its great distance. Yet despite its immense scale, the Great Rift remains relatively obscure. While the Milky Way is full of similar dark patches, these mark areas where stars have been obscured by interstellar dust, preventing us from seeing through them. The Great Rift, however, is unique. Over millions of years it has grown larger, becoming a prominent feature that scientists are keen to understand better. The valley is actually a wall that separates the constellations of Sagittarius and Scorpio from the rest of the galaxy. Astronomers believe the rift formed when a group of small satellite galaxies crashed into the Milky Way. Today, the galactic wall remains a boundary between old and young stars, containing some of the oldest stars in the galaxy, as well as a wealth of gas and dust that could fuel new star formation. Hubble's sharp vision has helped map the rift's structure, revealing an area of intense activity where new stars ignite and explode, shaping the very structure of our galaxy. The death of a star. Here we see a dying star. The Crab Nebula is located 6,500 light-years away and is the remnant of a star that exploded as a supernova about 300 years ago. This image combines data from Hubble's visible light and X-ray instruments, creating a striking portrait of a celestial object in transition. The bright central star is actually a neutron star, the extremely dense core left behind after the star's explosion. Around it, glowing filaments and knots of gas and dust expand outward at tremendous speed. Hubble has captured this stellar graveyard in various stages, showing how the expanding shell of material evolves over time. The colors represent different elements and energy levels, including oxygen, neon, and iron. Studying these remnants helps astronomers understand the life cycles of stars and what happens to their remains after they die. The Crab Nebula, once a normal star like our Sun, serves as a reminder of the grand sweep of cosmic events that shaped our universe. The Red Rectangle Nebula. We now turn our attention to the Red Rectangle Nebula, located in the constellation of Orion. This 4,000 light-year distant object appears as a bright red hourglass shape in this Hubble image. At first glance, it might seem like a simple emission nebula, a cloud of gas and dust glowing from nearby hot stars. But the red rectangle has a secret. Hubble's infrared vision reveals a second set of hourglass-shaped structures lurking behind the emission nebula. These mysterious features are pockets of dense dust and gas, marking the birthplaces of new stars. The interaction between these stellar cradles and the surrounding gas creates shockwaves that drive powerful jets and winds. These outflows push the gas of the emission nebula into elaborate shapes. While carving tunnels through it, the reddish hues indicate highly energized hydrogen gas, common in regions of active star formation. The darker silhouetted areas are cold, dense cores where stars are just beginning to form. Captured in a single frame, this dynamic range of features offers a rare glimpse into the life cycle of stars. Andromeda Galaxy. And now let's shift our focus from star formation to galactic evolution. Here we observe the Andromeda Galaxy, our closest major galactic neighbor, approximately 2.5 million light-years away. This majestic spiral galaxy is almost a perfect twin to our Milky Way, making it a valuable case study. However, don't be fooled by its tranquility. Andromeda is hurtling toward a collision course with the Milky Way, though the first expected contact won't occur for another 3.75 billion years. This image offers a preview of what's to come. It's the majestic spirals. Rich star clusters and dark dust lanes are all clues to the complex interactions that will play out over billions of years. Astronomers closely monitor Andromeda to understand how galaxies evolve over time. Hubble's unique perspective has revealed intricate details like tidal tails streaming from the galaxy's core. As the two galaxies draw closer, their gravitational interactions will trigger bursts of star formation. Eventually, they'll merge to form a single elliptical galaxy. This cosmic collision, while cataclysmic on a galactic scale, provides an opportunity to study how galaxies evolve and interact. Black Eye Galaxy. In the constellation of Coma Berenices, approximately 30 million light-years away lies the Black Eye Galaxy. This striking spiral galaxy earned its name from the large, dark dust cloud obscuring its core. This image combines visible light and infrared data, giving a striking three-dimensional view. Zooming in, we see a galaxy in action. Stars are born in the glowing pink and red clouds of gas and dust. The bright core contains a supermassive black hole, actively pulling in surrounding matter. As gas spirals into the black hole, it heats up dramatically, emitting immense energy. This active black hole drives powerful jets that punch through the galaxy's core, carving out a spectacular cone-shaped feature in the dust. The Black Eye isn't just a cosmic spectacle. It's a living example of a galaxy in flux. Scientists use it to study everything from star formation to supermassive black holes. Nebula in the constellation of Aquarius. Turning our gaze to the constellation of Aquarius, we encounter this mesmerizing scene. Captured by Hubble, this image showcases a star-forming region in the IC 434 nebula, located approximately 580 light-years from Earth. The vibrant colors bring to life interstellar clouds of gas and dust, showcasing the dynamic range and beauty of our universe. The bright red hues dominate the image, signifying the presence of ionized hydrogen gas, a common element in star-forming regions. These glowing clouds are cradles of stellar birth, where gravity pulls together immense clouds of gas and dust, eventually igniting nuclear fusion and giving rise to new stars. Within these stellar nurseries, stars of different sizes and temperatures shine brightly against the backdrop of the Milky Way. Some are surrounded by disks of debris left over from the process that created them. Others, like the trapeze stars, shine with a multitude of colors indicating their variable surface temperatures. Observing these stars in various stages of formation helps astronomers better understand how stars like our Sun evolve over time, the birth of a planetary system. Transitioning from stellar nurseries to the formation of planetary systems, we direct our attention to the Sigma Octantis system, located about 13,000 light-years away. This system provides a fascinating view of a disk of dust and gas orbiting a young star. Captured by Hubble's keen eye, this image highlights the complexity of celestial bodies in motion. The swirling dust and gas in the disk are remnants from the star's initial formation. As the material condenses, it forms a rotating disk and begins clumping together under the influence of gravity. These clumps will eventually grow into planets, moons, asteroids, and comets. The glow around the star results from material being pulled from the disk and heated to extreme temperatures. Studying such systems helps scientists learn about the building blocks of planetary systems, shedding light on the conditions that shaped our own solar system billions of years ago. These celestial wonders are just a fraction of what the Hubble Space Telescope has revealed. From the birth of stars to the depths of space, Hubble continues to unlock the secrets of our universe. And that concludes our journey through the cosmos. Below, which of these images left you in awe? Did any particular wonders surprise you? Feel free to share your thoughts. If you enjoyed this experience, please support us. Your engagement fuels our passion for exploration. Till next time, keep looking up and embracing the mysteries of the universe. Thank you for joining me on this journey through the cosmos. If you found wonder in the vast expanse of space, I invite you to join our community. Your support means the world to us. Keep asking questions, keep searching for answers, and above all, keep looking up. The universe has endless wonders to reveal to those who dare to dream.